Good afternoon. Thank you for joining us here at the NASA Johnson Space Center for part 2 of our briefing on the Alpha Magnetic Spectrometer spacewalks that are coming up to start at the end of this week. If you joined us for the last briefing, we went over some of the high-level details, what's happening on the activities aboard the International Space Station, as well as the high level of what this Alpha Magnetic Spectrometer space experiment is all about. Right now, we're going to be going into the details of the spacewalks themselves, again, that are set to start this Friday, November 15th. To my right are the experts that have been leading the large teams that are about to conduct this series of very complicated spacewalks to repair this experiment. Immediately to my right, Tara Jochim, the spacewalk repair project manager. Down the line, we have John Mularski, who's the lead spacewalk officer, will be leading the teams in mission control through the tasks of the spacewalk. And of course, Jeff Radigan, the flight director for the flight teams in Mission Control Houston through these upcoming spacewalks. If you have any questions online, use the hashtag AskNASA. And if you're joining us by phone, please just make sure to press *1 to submit a question. And we'll be asking those after some opening comments from our briefers. Tara, I'm going to pass it over to you first as the project manager. Take us through some of the work that's been done to prepare for these spacewalks.
Sure. This has been a really challenging time period for this community, and we're really excited that we've reached this point finally of being able to go do the EVA this coming Friday. Friday will actually be the 4-year anniversary of when NASA decided, yep, we're going to go off and pursue the repair of this great science experiment. So in the last briefing, we talked a little bit about the challenges associated with this. When we first started this, we weren't really even sure if we were going to be able to complete the repair successfully. We've kind of bitten it off one bite at a time and really done a nice job of buying down the risk associated with these challenges and whether we're going to be successful. I think we're pretty confident as a team now that we've done the best we could do for that, and we're looking forward really to the crew getting out the door. Lots of different technical challenges. Usually when you go out for a spacewalk, you're working on a piece of hardware that was prepared for on the ground for a spacewalk. It meets all the requirements and sharp edges and loading and all those items that we usually have in place for us. We did not have that opportunity on this one to get those things done. So those were some of the first things we had to think about when we approached this payload in particular. How could we create a work site? How could we make it safe enough for the crew member to work there and the activities they needed to do? Then we needed to tackle the actual challenge of how do we fix this thing? We're going to go in and actually bypass the cooling system that's on AMS. To do that, you've got to cut into these small stainless steel tubes that are on AMS. That presents its own unique challenges, just the how do we do it. But how do you keep the crew member safe to do that? You're creating sharp edges, and when you're inside kind of a large balloon yourself, you don't want to come up against sharp things. So we had to figure out how to safely go off and do that activity as well. In that whole process, we developed a whole lot of new tools. We usually have a standard set of EVA tools that we design all of our space equipment to be able to interface with. Unfortunately, not all those would work on this activity, so we had to go off and design about 25 new space tools that we flew on a variety of missions this year to get it up to space station. We covered all the different vehicles that we have here going to space station. We launched on the 3 different cargo vehicles that we have, the SpaceX vehicle, HTV, Japanese vehicle, and the Northrop Grumman vehicle that just recently came to station. So all those vehicles carried all these tools and hardware uphill, and we're ready to go see those guys get out the door and use those things. We had a couple of the challenges to talk about that we faced were a lot of non-captive fasteners. We have a pretty good history throughout the Hubble program of being able to capture some of these non-captive fasteners. So we reached out to our Goddard friends that worked these items in the past and brought them on board to help us kind of incorporate their knowledge and their lessons learned. So they became a part of the team along with our Johnson Space Center EVA tools teams, able to incorporate their knowledge and bring some of those older tools and make them fit for the designs that we needed today. Some of the other things that we were able to do was reach out to some of the college programs that we have around here and put out a call for a solution to one of the challenges that we have. One of the unique things that we're doing on this AMS set of EVAs, besides cutting stainless steel tubes, is we have a number of zip ties and lacing cord and possibly some MLI that will need to get cut when we're in these EVAs. So we put out a call and said, you know, can you come up with a solution, a simple solution that would allow a crew member to be able to access the work site and get in there and cut these zip ties? Part of that solution set had to include capturing that zip tie when you're done with it. In your garage, that may not sound like a big deal. You can go off, snip your zip tie with whatever scissors or whatever tool you have, let that zip tie fall to the ground, clean it up, and put it in the trash can. Unfortunately, on space, we don't like having debris floating around the space station. So part of that solution had to incorporate holding on to that zip tie. So we had a real nice solution come forward through one of the tools, through one of the schools. They kind of modeled this tool, called the zip tie cutter, modeled the tool after a ballpoint pen concept. So they're able to, the crew member would be able to reach into a work site, attach this item to the zip tie itself, kind of slide underneath it and depress the handle here, and it has a blade that comes in and cuts that zip tie and captures it. Allows the crew member to be a one-handed actuation, pull the item back out and put it into the trash can. Once they're in the trash bag, they're able to just release it and the zip tie goes away. So it was neat to be able to not only engage our engineers here in Houston and at Goddard Space Flight Center, but to be also reach out to our more local community and be able to engage these young science and engineering students into this process and hopefully get them excited about the things that we do here and the things that they have possibilities of doing in the future. So simple things like that were really helped make this project exciting, so to speak. So lots and lots of technical challenges to us here as we step forward to Friday. Really looking forward to the opportunity to just have a lot of lessons learned to just add to all of our capabilities of spacewalking that we've done here in our history of NASA. So with that, I'll pass it off to Mr. Mularski.
All right. So we'll go through some of the sequence of the EVAs, the details of the repair. First off, we've got a video of EVA 1, talk through kind of how we're going to access the work site and give you kind of an overview of where we're going. So we can play that video. Crew will be starting out on the first of the AMS repair EVAs. Here we've got Luca Parmitano as EV1 and Andrew Morgan as EV2. Luca is here picking up the whiff extender to install on the end of the Canadarm2, while Drew is bringing out some tool bags, stowing them on the outside of the airlock, and also bringing some with him to translate up the truss as well. Here Luca is proceeding up to meet the Canadarm2, where he will start configuring that for the start of this repair series. From here, Drew will pass by Luca, head all the way out to AMS to the Express Logistics Carrier 2, where he will start setting up bags. Drew will make several trips between the airlock and the Express Logistics Carrier in order to bring all the tools for the repairs out to the work site and have them staged and ready for Luca's arrival with the SSRMS. So here Luca will be setting up the whiff extender, followed by the articulating portable foot restraint, which will give him the reach necessary to perform the repairs on AMS, since there are no handrails currently installed on that payload for repair activities. Once Luca has his tool bag and is on the end of the SSRMS, he will fly a sweeping range of motion that will take him well over top of the ISS, where he will get a great view of the space station and be able to take lots of video and photos that we can use to keep an eye on the state of the station. As the arm is stretched out and wrapped around the AMS, there will be several places of tight clearances the arm operators will have to negotiate for Luca's at the aft and outboard work site here. You can see him flying up over top of the truss, where the arm will wrap around the backside of AMS and push him in between AMS and the ELC in order to reach the work site to repair AMS's thermal pump system. Once Luca is at that work site, he'll be removing a debris shield, working with Drew to access the primary work area of the AMS repair. Here they're installing a handling aid that'll be used to handle this debris shield after it's removed. There are about a dozen non-captive fasteners that'll be removed in order to release this debris shield. Several will be under these capture cages and they'll be trapped that way, and several will be released using capture forks to be put into a separate capture block so that they are managed and not released as FOD. Once all the fasteners are released from the debris shield, Luca will hand it off to Drew, who will be in his own foot restraint, and he will face aft on the ISS and jettison that debris shield. Due to its large size, it is not easy to put that back at the airlock, so jettison is the optimum choice for that shield. Once the debris shield has been removed and jettisoned, Luca and Drew will work together to install other handrails. Here we've installed the first 3 handrails, the diagonal beam handrail. Then Drew will hand over 2 more handrails that Luca will install, that they are the vacuum case handrails. This will allow Luca and Drew better access and mobility at the work site in preparation for the 2nd through 4th EVA of the series. Following the handrail installation, crews will close up their tool bags and make their way back to the airlock. Here Luca is on the end of the arm and will repeat his translation on the end of the arm back to the front of the truss. While he's flying on the arm, Drew will translate around the outside of the ELC and translate back under the mobile transporter back to the airlock for the end of the first of the AMS repair EVAs.
All right, so that gives you an overview of the work sites on EVA 1. Throughout the course of the EVA series, the crew will be returning to those work sites on the end of the SSRMS with Luca, and then Drew will be free float. So to get into some of the tools that we talked about a little bit in that video, so the debris shield with those non-captive fasteners, as Tara mentioned, we have to find some way to capture them. And so this is a tool that was heritage from Hubble and built by Goddard, that has a hex bit that allows us to rotate the fasteners to start them. Then you kind of retract it, and these forks here then allow you to scoop the fastener underneath and push it forward again, and it allows you to finish extracting that fastener, and then it's captured between the forks and the bit. And once you've got the whole of the fastener is released from the debris shield, you've got a fastener capture block with numbered fasteners. You push the bit into the hole, and the screw stays behind, and you can move on to the next one. And so the crew will work their way around the debris shield for several of those fasteners and install them in that block. Now, one of the sides of the debris shield didn't allow enough access for the capture fork style design, so Goddard designed this capture cage. So what this does is, instead of having removing the fastener and taking it away and putting it in a capture block, we're actually going to leave the fastener in place trapped to the shield. So this capture cage installs to the side of the shield and essentially closes out the side of the shield with a small box. The crew can then insert a fastener bit into the end of the capture cage through this hole, and when they release the fastener, it'll just rattle around inside the cage, and so it'll be released from the shield, allowing the shield to come off, but it will be trapped by this cage, and then the cage will be permanently attached to the shield when it's jettisoned. So there'll be 3 of these that the crew will have to install and use to release. And so that, between this and the capture tools, they'll work their way around the shield to release all of the fasteners and remove the debris shield, which is the main focus of the first EVA. So if we get through the removal of the debris shield, it'll be a good, successful first EVA. Following that, they'll have to move under the debris shield, actually to the work site itself. And as Tara mentioned, we'll be cutting numerous stainless steel tubes. Of course, since they weren't identified pre-flight as a way to cut them, we had to figure out how to label them. So they also built these templates that you install on the tubes, and they'll be per arrow lines up with each of the tubes. And it tells the crew members in green where to cut, which tubes, and in red where not to cut. That way, they can take an item that's not currently labeled, and they know which one's which. They can cut those, and then they have caps that they actually install on them, which they then use to label the tubes for when they come back later. So the main focus of the second EVA will be accessing those tubes themselves, cutting them, and then labeling them, and installing some of the MLI. Once we've accessed all the tubes and they're all cut, the crew, as was mentioned in the earlier conference, they'll bring out the new pump system itself and hook that up to AMS, and hopefully go through successful swages and successful leak checks, and that'll finish out the series with brand new pumps and brand new MLI covering it all up.
Thank you, John. Very complicated, and you can see the amount of work and intricate detail that had to go into designing these tools. Jeff Radigan, we'll take it to you for the flight teams.
Yeah, it's been a fantastic road to get here. As Tara mentioned, it's been a long road for many of the folks who have been working this. It's been a very a very stressful one in order to get through all of the work that's needed to happen in the short amount of time that we've had in order to ensure that we're able to fix AMS and continue the great science that it's doing. I'll tell you that the flight crew and the flight control teams, very ready to go do this. We're all excited about it. Talking to Luca and Drew last week, they're excited to get out the door. As you can imagine, they've been training for a couple years to go do this, and anytime you spend that much time getting ready for something, of course, when the day comes, you're more than prepared and excited to go make it happen. It's just been a fantastic road and a fantastic team. I do want to mention just all the various folks that have been involved in developing all the AMS work. As Tara mentioned earlier, we've had tool support from the Goddard Space Flight Center. We've had work from the ISS program, and then, of course, all of the operations teams that have been involved in getting us to this point. And it's just really remarkable that we've gotten here, and we're excited to go do this. Friday is going to be a great day. It's a great opportunity for us, and we really look forward to kicking off the series of AMS EVAs. I'm sure we'll learn something along the way, and I'm sure that there's always the possibility that something won't go right, but we're prepared and we're ready to handle that.
Thank you very much, Jeff. Now, to reiterate some of the details from the last briefing that we had, we are again kicking off this series of spacewalks this Friday, November 15th, and then we'll look forward to the following Friday, November 22nd, for the second spacewalk. Right now, we're planning for a series of 4, so we'll see how those first 2 go, and then we'll look at the dates for the next 2. Our 2 spacewalkers are Luca Parmitano of the European Space Agency and Andrew Morgan as a NASA astronaut. Both of them experienced spacewalkers, so we'll look forward to some of the spacewalks that they have to do. They've been, again, as these briefers have mentioned, training a lot and preparing for these upcoming spacewalks. So it'll be an interesting time to finally kick these off. So we will now open it up for questions. We'll start here in the room, and of course, we'll take questions by phone and on social media. Just to reiterate one more time, if you're on the phone, use that *1 to make sure you submit your name for a question, so we'll be able to call on you. And then for those of you joining by social media, use the hashtag #AskNASA. So we'll start here in the room. Mark, if you can say your name and affiliation.
Sure. Thank you. Mark Carreau with Aviation Week in Space Technology. I'm kind of winding back to the first briefing and trying to merge something with the detail you provided. Once the outer cover is off, does the carbon composite cover come off during the first or second spacewalk in order to get to the intricate plumbing? I think I got a little bit lost on where that falls in the work.
Yeah, absolutely. So the carbon fiber covers is on the second spacewalk. So primarily the first spacewalk is the debris shield, as we mentioned. The second spacewalk will open up some MLI, we'll cut the lacing cord using the zip tie cutter, as Tara mentioned, and that's when we'll be faced with that carbon fiber cover. So another dozen non-captive fasteners to be removed with that red bit that we showed there. Then we snap that cover off and jettison that one, and then we're access with the tubes. And so hopefully at the end of that EVA, then we'll be cutting those tubes in prep for the box, the new pump to come out on EVA 3.
Wonderful. Yeah, these are very, very complicated spacewalks. So any questions of the details, this is the perfect time to ask. We'll go to Bill Harwood on the line. Bill.
Yeah, thanks, guys. 2 questions from me. One is similar to a question I asked in the first briefing in terms of the complexity of these EVAs compared to other things. I mean, you guys have done some remarkable events in EVAs over the years, dating back to the start of the shuttle forward. Where does something like this stand in terms of complexity, the challenge of training and everything? It almost sounds like this must be at the top of the list. And then my second question is, you mentioned breaking off that carbon panel on EVA 2. Can you tell me, is that a material that just snaps when you bend it back? Does it kind of metal fatigue and slowly fail? In other words, is there any risk involved with breaking off a panel like that? Thanks.
Well, I would say 2 very good questions. Thank you for those. To tackle how challenging this prospect is of doing these EVAs, I would certainly say it's definitely towards the top of the list, if not on the top of the list. Hubble, some of the benefits of Hubble was that they had an entire space shuttle mission designated to go off and repair that specific activity, whatever part of the Hubble they were going to go repair. Hubble, for a majority of that, was designed to have EVA walk on it. None of the AMS area that we're going to was designed that way, so we had to go off and figure out how to create a work site. We had to build new handrails to be able to install on existing hardware, had to deal with existing sharp edges, and in a lot of cases we're creating new sharp edges using tools that have sharp edges on them. So, we did as much as we could to minimize that risk to the crew member and then of course to the mission success of the payload itself. But they are certainly very challenging, technically difficult EVAs. Our crews we did not have here in town nearly as much as the opportunity that the Hubble crew had to train. John's probably got some details on that. While we did dozens of Argos evaluations, both during our development for tools and the actual training part, and I don't know, roughly 20 NBL runs, I think, that was not all with the crew that's going out the door to go do these activities. So John, I don't remember what the exact details were for the training of the crew.
So this crew did 7 NBL runs specifically for AMS training itself, which is more than we typically do for ISS EVAs, but that's due to the complexity and the amount of tools that we've created for them. Yes, we had to also do a lot more runs, as Tara mentioned, without that crew, so we could finalize our timelines, finalize the tool usage, and we've had to then walk the crew through those new details in the last week or so. And so there was a bigger gap. For Hubble, you would have launched the crew and then done EVAs right away, but here we've got the ISS increment flow, and you've worked those EVAs into the timeline as they're able. So for the second question on the carbon fiber cover, it does snap pretty cleanly. When we've done it in testing, we've done probably a dozen of them now in testing and training. You pull on it and it kind of flexes and bends to a point where it does crack. And as you continue to go, you do have to work it a little bit to finish breaking apart all of the carbon fiber covers. But it breaks cleanly and repeatably in the same place every time we've done it on the ground. So.
Yeah, if I could add, one of the things you'll hear throughout all of the EVA sequence, right, is the managing the risk of sharp edges. And that's a continuous thing that we're aware of. I think one of the nice things that we have that's different than what EVAs in the past had is just the amount of on-orbit training that we're able to give the crew, the amount of training videos that we're able to send them, the amount of video conferencing we're able to have with the crew to show them exactly what we're worried about and to augment the training that they receive pre-flight now when it's time to go perform. And so when we talk about how to manage the risk, the biggest thing is knowing it's there and to be prepared for it. And I think we've done a great job of educating them and educating ourselves here on the ground about the risks that we're going and dealing with and going to manage to where it makes it manageable and it's not something that's going to catch us off guard and it's something that we're able to work through.
Thank you. Thank you for your question, Bill. We'll now move over to social media. Again, if you want to continue to ask questions, use the hashtag AskNASA. Leah, what do we have on social?
Marsha wants to know what the success criteria are for this spacewalk. Would that be fixing all of the pumps, or if you can get just one working, is that also considered a success?
I think we very much like to judge success in completion. We want to get AMS working again, right? Let's leave it at that. We want to get as many pumps as required to work. Some of those are redundant. And so if we get it to the point where AMS is able to gather all the science data, we would call that success. That doesn't necessarily mean every pump works, but it means we get to the point where the instrument is, again, getting us the great data that we're so appreciative of.
Great. I think we have another Ask NASA question.
Yes, this one's from Marco, who wants to know if there are other astronauts trained on the Alpha Magnetic Spectrometer repair tasks apart from Andrew Morgan and Luca Parmitano.
So with the complexity of these tasks, we did focus our training on Drew and Luca. They were the ones that were in country at the right time to get the MBL runs. And so they were the ones that received that training to go ahead and do those tasks on orbit.
We did, though. I'll add to that. We did what was unique, I think, to add into what else makes AMS special is we had a lot of crews that were involved all the way through our development time frame associated with the tools and what the procedures are going to be, and frankly, just how are we even going to approach this work site. So there's several crew that are here on the ground that are well versed in AMS, would need some more training if they were to launch and go perform any of these activities for sure. But they can at least spell AMS and know know how to move forward on it. So, yeah.
Wonderful. Let's do a few more Ask NASA if we have them.
Yes, Yes, we do. We're getting some good questions. We have one from Veronica who wants to know if the AMS will remain without a debris shield.
So yes, the debris shield, there won't be a new one installed. Instead, we'll close it out with MLI blankets. Due to the position of AMS, that debris shield isn't needed in the future, and so we'll just close it out with some MLI blankets that will protect the area that we've opened up after the debris shield is removed.
Okay, and this one from James who wants to know how the AMS coolant system will be depressurized before cutting.
So there is actually, so we're actually going to cut to depressurize the system. So there's the lines that were connected to the box itself, the pump box itself, but there's actually a line that was used to fill the system. So the crew will actually utilize the cutters to cut that line, and it's under MLI and aimed in a direction that'll be a safe vent, but that's how the system will be vented down before we get into the main part of the repair.
These are wonderful questions on hashtag Ask NASA. Thanks so much for continuing. We'll do one more sweep of the room, see if there's any more questions or online. Again, just press *1 before we wrap up. If not, I'd like to thank our briefers for coming and describing these intricate details. There's been a lot of work to get to this moment. I think it was 4 years was when, from the, as you said, the anniversary of when we started looking into this. So it's a lot of work by all teams to actually make this happen. If you want to tune in to the spacewalks, the first one is set to kick off on Friday, November 15th. Check NASA TV for the schedule on when that will begin. Early in the morning, it'll be Luca Parmitano and Andrew Morgan heading out the hatch, assisted by the many teams here on the ground, as well as their team aboard the International Space Station. Again, one final thank you to the briefers here for going over these details, and continue to ask those questions on hashtag NASA. We'll be answering them on some of our coverage through these next spacewalks that we'll be covering over the next few weeks. Thank you for joining us here at the NASA Johnson Space Center.